The findings of the James Webb Space Telescope, JWST, have significantly challenged the Big Bang Theory. Welcome back to the Joe Rogan Experience. Today, we delve into a groundbreaking revelation from NASA that's causing a stir in the scientific community. After 2 years in space, the JWST has made a discovery that's nothing short of terrifying. Join us as we explore this monumental finding of a cosmic visitor, its implications for our understanding of the universe, and what it means for the future of space exploration. Buckle up because this episode is going to be out of this world. In 2017, an extraordinary milestone was achieved in astronomy with the identification of an object named Oumuamua. This remarkable discovery marked the very first observation of an interstellar object passing through our solar system. The impact of this finding is profound. Before Oumuamua, astronomers focused on studying objects within our solar system. Despite this focus, many phenomena within this familiar area remained unexplained. However, the arrival of Oumuamua opened a new field of exploration, giving researchers a unique chance to study a celestial body from beyond our solar system. This discovery has significantly expanded the scope of astronomical research. The arrival of Oumuamua was not just a random event, it was a significant cosmic occurrence that provided a rare opportunity to explore areas previously out of reach. This stirred great excitement among scientists who usually studied the familiar objects in our solar system. Suddenly, they were faced with a mysterious object from the far reaches of interstellar space. Calling this discovery groundbreaking doesn't do it justice. The study of Oumuamua was immensely important for several reasons. First, it gave scientists a rare chance to examine the variety and composition of objects from distant star systems. This was key to gaining deeper insights into the basic building blocks and formation processes of celestial bodies throughout the universe. By carefully studying Oumuamua's composition and structure, researchers sought to uncover important clues about its origin, the conditions it faced during its journey through interstellar space, and the processes that shaped its unique features. What they discovered was astonishing. Through detailed research, scientists gathered a wealth of information about Oumuamua's makeup and characteristics. These findings offered not just a look at a single object, but a wealth of knowledge about the conditions and phenomena influencing distant interstellar objects. Each piece of data collected from Oumuamua's study provided a pathway to a better understanding of the dynamics that govern celestial bodies traveling across the vastness of space. Oumuamua is quite different from the usual asteroids or comets we see in our solar system. It looks like a long rock, almost like a cigar. Typically, comets come from far away in our solar system, like the Kuiper Belt or the Oort cloud. These icy objects are usually made up of frozen gases, water ice, dust, and rocks. Unlike Oumuamua's long shape, comets are more round or irregular in shape, like dirty snowballs with different shapes and surface features. As comets get closer to the Sun, the ice inside them starts to turn into gas, releasing dust particles. This can create a cloud of gas and dust around the comet, sometimes forming a tail that points away from the Sun due to solar wind and radiation pressure. Comets can vary a lot in size, ranging from a few hundred meters to several kilometers in diameter. For example, Halley's Comet, which we often see in the inner solar system, has a nucleus estimated to be around 15 kilometers wide. While some comets might have larger nuclei, they usually have a similar shape and structure. What makes Oumuamua unique is its reddish color, which is different from the usual comets. This color is similar to objects we find in the outer parts of our solar system, suggesting that Oumuamua has a special composition or surface. Despite being close to the Sun during its journey, Oumuamua didn't have a coma, which is a cloud of gas and dust around the nucleus that regular comets have. This absence of a coma tells us that Oumuamua is not like the typical comet we're familiar with, it's something entirely new and different. The behavior of Oumuamua continues to interest scientists because of an unusual occurrence, its acceleration that doesn't follow gravitational rules. This acceleration shows that there are other forces at work besides the Sun's gravity. This intriguing behavior is due to two main reasons: outgassing and solar radiation pressure. Outgassing happens when volatile substances like gases or frozen materials trapped within the surface layers of a space object turn into vapor and get released into space. When a comet gets close to the Sun, the increased heat causes these volatile materials in its core to turn into gas and dust, creating a bright cloud around the core and forming the distinctive tail seen in comets. The fact that Oumuamua shows signs of outgassing suggests that it has similar volatile substances within it, like comets. This outgassing could be pushing Oumuamua, making it deviate from its expected path, which would normally be determined only by gravity. Solar radiation pressure also plays a big role in understanding Oumuamua's behavior. This force comes from sunlight pushing against objects in space. Even though each particle of light, called a photon, has a tiny amount of momentum, when many photons from sunlight hit an object, they can create significant pressure. Because of Oumuamua's long shape and the pressure from sunlight, it could be experiencing a non-gravitational acceleration. The combination of its shape and the constant pressure from sunlight might be causing the observed changes in its path, showing that there are forces at play beyond just gravity. While Oumuamua spins, its brightness changes dramatically by a factor of 10, which is much more than any asteroid or comet we know of in our solar system. Its spin takes about 7.3 hours, showing how much its brightness can vary. This uniqueness highlights how special Oumuamua is. However, figuring out its size is a real challenge. Different studies and observations have given different ideas about how big Oumuamua is, making it hard to pin down its actual size. NASA's Jet Propulsion Laboratory did a study suggesting Oumuamua could be anywhere from 320 feet to 1,440 feet in diameter, hinting that it might be spherical within this size range. On the other hand, NASA's Solar System Exploration Team thinks Oumuamua might be elongated, up to a quarter-mile long, and about 10 times longer than it is wide. This means it could be much longer than it is wide. But a recent study disagrees with these estimates, suggesting Oumuamua might be smaller, around 146 feet by 144 feet by 24 feet, much smaller than what was previously thought. Despite these different guesses about its size, one thing remains constant: Oumuamua looks like a cigar, which is a major characteristic that scientists are trying to understand better. To help with this, they're using the Pan-STARRS-1 telescope. The Pan-STARRS-1 telescope, located in Maui, Hawaii, is essential for studying Oumuamua and other space objects. This telescope is part of a project involving the University of Hawaii Institute for Astronomy, NIT Lincoln Laboratory, Maui High Performance Computing Center, and Science Applications International Corporation. The project uses advanced cameras and computer systems to continuously scan the sky, identifying moving or changing objects and providing detailed information about them. Since beginning its scientific operations in May 2010, the Pan-STARRS-1 telescope has been instrumental in discoveries like Oumuamua. The Pan-STARRS-1 telescope is particularly well suited for studying objects like Oumuamua due to its unique wide-field optical design. This design allows the telescope to survey a large portion of the sky during its observations, increasing the chances of detecting faint celestial objects that might otherwise go unnoticed. It has an impressive field of view covering 7 square degrees and a powerful 1.4 gigapixel camera. These features enable the telescope to collect extensive data and significantly enhance its accuracy in detecting and tracking celestial bodies, even those with very faint light. Additionally, the strategic location of the Pan-STARRS-1 telescope in Hawaii offers several benefits for studying objects like Oumuamua. The island provides clear, dark skies with minimal light pollution, creating ideal conditions for observation. This environment, combined with the telescope's high sensitivity to faint objects, was crucial in successfully detecting Oumuamua as it passed through our solar system. Oumuamua entered our solar system from the direction of the constellation Lyra. The exact origin of Oumuamua remains unknown. It may have traveled for billions of years across the galaxy before reaching and moving through our solar system. A new study in Nature Astronomy proposes an interesting idea about where Oumuamua comes from. The study suggests that Oumuamua might have broken off from a larger planet in another solar system, and due to the strong gravity of its home star, this planet piece was torn apart. The broken pieces were scattered into space, sending Oumuamua on its journey between stars after leaving its original solar system. One fascinating aspect of Oumuamua is how it unexpectedly sped up while passing through our solar system, a topic that scientists have discussed before. When it first entered our solar system, it was above the plane where planets orbit. It came very close to the Sun, just 0.25 times the distance from Earth to the Sun, and then moved below the planetary plane. Throughout this journey, Oumuamua maintained a high speed of about 196,000 miles per hour. This super speed indicates the significant energy it possessed during its trip. The fast speed might also be due to how Oumuamua is made. Scientists have learned that Oumuamua has a tough outer layer composed of carbon-rich material, hardened by cosmic radiation during its long journey between stars. Inside, it is dense with rocks and possibly some metals. However, unlike most comets or icy objects in our solar system, Oumuamua lacks any water or ice. Its surface appears reddish, likely due to being bombarded by cosmic rays for millions of years, which altered its appearance and made it distinct from other space objects. The discussion about Oumuamua's origins has become even more intriguing as experts consider the idea that this object could be something made by beings from another world. This theory arises from some unusual characteristics of Oumuamua that don't fit with what we usually observe in space. One significant anomaly is its shape. Rather than being round or irregular like most celestial objects, Oumuamua is long and cigar-shaped, which is highly unusual. Additionally, Oumuamua's movements didn't follow the expected patterns dictated by gravity, leading some to speculate that it might have been propelled by a different kind of technology or engine, perhaps something like a light sail that uses energy from stars to move. This theory suggests that Oumuamua could be part of a spacecraft built by advanced aliens, intentionally sent to explore other star systems. Another oddity is that Oumuamua lacked the tail or gas emissions typically associated with comets or asteroids. Proponents of the alien origin theory suggest that these aliens might be using a propulsion method unknown to us, beyond our current scientific understanding. They also propose that the absence of a tail or gas emissions could have been a deliberate choice by the aliens to avoid detection. These ideas suggest there is much more to discover about space and the possibility of life beyond Earth. The unusual reddish color of Oumuamua's surface adds another layer to its mystery. Some theories propose that this color might have been deliberately chosen by potential alien creators, possibly using substances that react with space radiation to produce this distinct hue. This intentional coloring could serve as a form of camouflage, helping Oumuamua blend in with other reddish celestial bodies in distant star systems. If this is the case, it raises the question, why would an alien-made object want to conceal itself while exploring other solar systems? Imagine an advanced extraterrestrial civilization residing in a distant star system. Equipped with highly advanced technology, they can explore the universe and study different civilizations. Upon detecting Earth and its signs of life, they become intrigued by our planet and its diverse life forms. Captivated by what they observe, they decide to send a reconnaissance mission to gather information. In this narrative, Oumuamua could be viewed as a vessel crafted by these extraterrestrial beings. Its distinct shape and materials might be designed for safe travel between stars, with the elongated structure helping to minimize the impact of space debris and ensure stability during its extended journey through the cosmos. Oumuamua stands out not only because of its shape but also due to its unique movement pattern. It appears to travel through space in an advanced manner, allowing it to cover long distances and maneuver effectively. This exceptional mobility could enable it to explore various areas freely and avoid obstacles in its path. Equipped with sophisticated sensors and advanced communication devices, Oumuamua may possess the tools needed for its mission. One of its primary roles could be gathering confidential information about Earth, including details about our atmosphere, surface, and any signs of intelligent life. Once it gathers this data, it could transmit it back to its creators, providing them with valuable insights about our planet from a distant perspective. The peculiar actions of Oumuamua, initially approaching Earth and then abruptly changing course, could fit into this narrative. It's conceivable that it completed its data collection mission and departed from our solar system. This sudden change, while puzzling, aligns with the notion that it accomplished its objectives and moved on. Oumuamua's distinctiveness compared to other celestial objects raises questions and hints at aspects of the universe that remain beyond our current understanding. Validating or disproving this intriguing concept is challenging due to Oumuamua's uniqueness, which presents difficulties in using our existing tools and observations to investigate further. An in-depth study of Oumuamua presents a significant challenge that requires careful planning and execution. To launch a space mission dedicated to exploring this mysterious object, scientists must create and send a spacecraft by 2028. This spacecraft must be specially designed to withstand the harsh conditions of outer space and equipped with advanced instruments capable of closely examining Oumuamua's structure, composition, and behavior. Once launched, the spacecraft will have the difficult task of reaching Oumuamua, requiring precise maneuvers. One suggested approach involves using Jupiter's gravitational force to propel the spacecraft forward, significantly reducing travel time. It's estimated that the spacecraft would take about 26 years to reach Oumuamua, depending on its speed and trajectory. Alternatively, scientists propose another route that utilizes the gravitational pulls of Venus, Earth, and Jupiter to achieve a similar time frame for reaching Oumuamua while minimizing the risks posed by proximity to the Sun during the journey. During its journey, the spacecraft will spend approximately 4 years using gravitational assistance from Earth, Venus, and Jupiter to adjust its trajectory and ensure accurate navigation. The goal is to rendezvous with Oumuamua between 2050 and 2054. Once the spacecraft reaches Oumuamua, it will enter a crucial phase of scientific exploration. Equipped with advanced instruments, it will thoroughly analyze the object's composition, shedding light on its origins, makeup, and unique characteristics. Detailed observations of Oumuamua's shape and behavior will be conducted to uncover its secrets and gather essential data. Communicating with Oumuamua is quite challenging due to its significant distance from Earth. To overcome this, an advanced communication setup is required, possibly using the latest technologies or a network of relay stations to bridge the vast space between us and Oumuamua. One promising option is to tap into NASA's Deep Space Network, which has specialized antennas designed for long-distance communication. These antennas are equipped with powerful transmitters and sensitive receivers that can capture signals from the spacecraft and send crucial data back to Earth. Beyond the usual radio wave communication, there's also the potential of using laser communication systems. These systems use focused laser beams to transmit data much faster than radio waves, which could be a game changer. Looking even further into the future, there's the exciting concept of creating an interstellar internet. This would be like a network of relay stations strategically positioned to transmit data from spacecraft to Earth, similar to how data travels between nodes on the internet. However, this network would require significant advancements in communication technology and infrastructure to handle the vast distances in space. Spacecraft would need super-advanced transmitters and receivers capable of operating over such long distances, employing cutting-edge techniques to optimize data transmission. To minimize signal problems, another idea is to team up with projects like Elon Musk's Starlink, which aims to create a massive satellite network in low Earth orbit for global broadband. Using Starlink's thousands of satellites could boost communication for missions to Oumuamua. To improve the spacecraft sent to explore Oumuamua, it could be equipped with a communication system that works with Starlink's network. This could help send data back to Earth faster, which would be great for studying Oumuamua scientifically. However, making this happen would need careful planning and cooperation between space agencies, private companies like SpaceX, and scientists. We'd have to think about things like making sure the communication systems can talk to each other, making the spacecraft's equipment work well with this setup, and ensuring the spacecraft and Starlink satellites stay in sync as they move in space. NASA and SpaceX already work together, so extending this teamwork to science missions might not be too hard. Even if we figure out how to communicate well, there are still many other important things to consider. Making a successful mission to study Oumuamua involves lots of details, like designing the spacecraft, making sure it can move well, collecting and analyzing data, and more. All of these parts need careful planning, testing, and creative ideas to tackle the challenges of exploring space between stars. Solving these problems requires experts working together, using new technology, and collaborating with everyone involved. As we try to understand more about objects like Oumuamua, far away in space, each step forward needs careful planning, strong commitment, and a willingness to learn more about the universe. Analyzing a unique celestial object like Oumuamua presents an exceptional opportunity for scientific investigation. However, it's a complex endeavor. Numerous technical challenges require creative solutions. Objects from interstellar space, such as Oumuamua, need advanced tools that can withstand the harsh conditions of space. Engineers and scientists must create state-of-the-art equipment that functions perfectly in the extremely cold and highly radiated environment of interstellar regions. This requires not only innovation but also rigorous testing to ensure the spacecraft's reliability and the effectiveness of its tools. Exploring the unknown comes with risks. The exact nature and composition of Oumuamua are still unknown. This uncertainty introduces the possibility of unexpected dangers during the mission, from encountering hazardous materials to exposure to high levels of radiation or the threat of micrometeoroids. Scientists and engineers must carefully assess these risks and develop strong strategies to protect the spacecraft and ensure the safety of the mission. Navigating and controlling the spacecraft's path to reach Oumuamua is also challenging. It involves precise navigation and complex maneuvers. Aligning the spacecraft's trajectory with Oumuamua's and making necessary adjustments requires great accuracy. Even a small mistake could result in missed opportunities or collision risks. The key lies in accurate trajectory calculations and reliable propulsion systems crucial for a successful mission. Despite our preferences, financial constraints play a significant role. Launching a mission of this scale requires substantial funding and advanced technology. Securing enough money and support from space agencies and governments while dealing with other important space exploration tasks is tough. To solve these problems, we need good plans, partnerships, and coordination among everyone involved. However, this is not easy, especially with many other important things on Earth needing money too. But this doesn't mean we can't keep learning about this interesting thing. Right now, there are things we can do here on Earth. One way is to use telescopes and tools to study Oumuamua. Even though we can only see it for a short time, astronomers collected useful information when it passed through our solar system. These observations gave us some initial ideas. Now, with all this information, scientists worldwide can work together to find out more. They can combine their knowledge to dig deeper and learn more from what we already know. By using the information we have and working together, scientists can uncover more secrets about Oumuamua without needing to go on a difficult interstellar journey. This way, we can use our current resources and knowledge to learn more about this mysterious visitor from outside our solar system. Determining the path that Oumuamua travels has been very important in figuring out where it came from and where it might be going. By calculating its route, scientists have gotten a peek into its journey between stars, showing the part of space it probably came from. Even though we don't have a lot of direct information about Oumuamua, these calculations help us understand how objects from other star systems move around in ours, which is a big achievement. Using computer simulations is key in studying Oumuamua. Scientists make virtual models based on the data they have, allowing them to test different ideas about what it's made of, how it behaves, and where it might have come from. These simulations are really important because they help us learn more about Oumuamua's properties and how it travels between stars. Another way scientists study Oumuamua is by looking at what it's made of. They use its spectral signals and do chemical tests to figure out what elements are in it. This kind of analysis can give us important clues about how it formed and what it's like. Recent studies suggest that Oumuamua might be from a comet, mostly made of nitrogen ice, showing how chemical analysis helps us uncover its secrets. Comparing Oumuamua to other objects in our solar system and beyond is also super helpful. By looking at similarities and differences, scientists can understand what makes it unique. This kind of comparison is really good for getting a broader view of what celestial objects are like. In the future, there are exciting opportunities to learn more about objects like Oumuamua. Another big cosmic mystery James Webb is unveiling is black holes, the cosmic giants that devour everything in their path, including light itself. These black holes were formed from the dying remnants of enormous stars and have gravitational pulls so strong that they distort space and time, entangling everything inside their gravitational grasp, including time itself. Now, a discovery uncovered by the James Webb Telescope challenges the fundamental basis of our knowledge. Just how does this discovery cast doubt on our long-held beliefs of how galaxies came to be? Does this cosmic aberration pose a threat to Earth? Black holes are a tricky bunch. It was quite a challenge to search for the first one, even though Einstein's theory of relativity predicted that they were common. Black holes, in contrast to stars, do not give off any light of their own, making their size and spin the only properties that can be measured about them. We now have photographic evidence of black holes, thus we know they exist. However, conclusive proof of black holes has been lacking for quite some time for scientists. Cygnus X1 was the first to be found in 1964. Stephen Hawking and Kip Thorne, two of the foremost authorities on black holes, did not reach a consensus on whether Cygnus X1 was indeed a black hole until over 30 years later. Hawking was quite certain that black holes did in fact exist. They were, after all, a major emphasis of his professional life. However, the question of whether scientists could actually locate one remained unanswered. Naturally, Hawking was a little anxious about the lack of findings, so he hedged his bets with his studies. He also mentioned that he and Thorne were almost positive that Cygnus X1 was a black hole in 1975 when the wager was initially cast. They were both 95% sure by 1988, according to Hawking. Still, they came to an agreement. The bet couldn't be finalized until they were both absolutely certain. Hawking was compelled to relinquish the bet in 1990 when more observations of the system had accumulated sufficient proof that it contained a black hole. Thorne claims that Hawking waited for the right time to concede defeat. 2 Geiger counters were launched into space on a suborbital rocket, which led to the initial discovery of Cygnus X1. A signal was detected by the Geiger counters, which astronomers were able to pinpoint to a system 7,200 light-years away, featuring a blue supergiant star surrounding another large object. The second object, they determined, was also strongly radiating X-rays, which would make sense if it were a black hole. Research has focused on Cygnus X1 since it was discovered in 1964. The first black hole in the universe, however, has more surprises in store for scientists. New research shows that the black hole is really 21 times the mass of the Sun. This object has the distinction of being the largest stellar mass black hole that has ever been found without the utilization of gravitational waves. This new finding, say the researchers, casts doubt on astronomers' long-held assumptions about black hole formation. The stellar winds that blow from a star's surface cause the star to lose mass to its environment. However, if we want a black hole this massive, we must reduce the mass loss experienced by brilliant stars over their lifetimes. Cygnus X1 breaks records in more ways than one. Its extraordinary bulk is only one of them. Cygnus X1 has the fastest rotational velocity of any black hole discovered so far, approaching the speed of light. A black hole with such a high spin also doesn't follow the accepted pattern of black hole evolution. Although definitive evidence of black holes has only just been discovered, it is becoming more and more apparent that they are scattered throughout the universe. Therefore, even if astronomers eventually untangle all the mysteries of Cygnus X1, the first of its kind, its countless kin surely still hold many surprises. Less than 2,000 light-years away from Earth, scientists have discovered a sleeping giant, the Milky Way's largest stellar black hole, with a mass 33 times greater than that of our Sun. Despite being the second closest known black hole to Earth, the dormant Gaia BH3 had remained undiscovered until now. Discovered by accident in a deluge of data and observations gathered by scientists from the European Space Agency, Gaia BH3 is located in the constellation Aquila, the Eagle. The group noticed something out of the ordinary as they went through data from the agency's Gaia mission, which is creating a 3-dimensional map of our galaxy. A star that was wobbling 1,926 light-years distant had a peculiar trajectory, indicating that it was ensnared in an orbit by a neighboring massive black hole. In order to confirm the mass of Gaia BH3, the astronomers and ground operators utilized the Very Large Telescope of the European Southern Observatory in Chile to validate their discovery. They revealed that once every 11.6 years, the wobbling star completes one orbit around the black hole. The discovery of the nearby, undetected high-mass black hole came as a complete surprise to everyone.